Mushu. Good to see you again, man. I was thinking about you last night when I was making these slides, because I ran your buddy Three Fingers.
Oh yeah, no, that guy owes me money.
He owes you money?
He was like investing in something called X. I don't know what he's talking about.
That's his mistake. But that sounds also weird. Like, oh, I was working these slides and I was thinking of you. That sounds dirty. It's not. All right, guys. So quickly for the stuff on the docket, this is the same as I showed last class. Homework 5 is due this Sunday. Then the following week, Project 4 will be due. Next week, the Tuesday lecture will be virtual over Zoom. That's our friends from Snowflake are coming to give a talk. And then the Thursday lecture will be back in class here in person. And that'll be Q&A session. Ask Andy whatever you want about databases. Well, there's no limits. And then the final exam will be Friday, December 16th. We have a room. I think it's Gates, the main lecture hall, 4401. And I'll post the study guide with the practice exam next week. And then actually on the Thursday class next week, we'll spend 5-10 minutes at the very beginning just to go over a quick final review. Okay? So there's a lot here, but any questions about anything that you guys are that's coming up? Okay, cool. All right, so this lecture is, as I said at the end of last class, this is my attempt to expose you to a different way of thinking about how to build applications and trying to use the database system more than just like a dumb data store. And we can talk about how now we can actually embed some of the logic that we would have in our application, so written in PHP, Python, JavaScript, whatever you want, and how we can start putting that into the database system. So to help motivate why we'd want to possibly do this, we first need to understand, well, how is it that applications are using the database system now? What's the most common approach? And the standard API, the standard method to interact with the database system is use what I'll call a conversational API, where the application connects to the database server, sends a query, waits for that result, gets it back, and then they're waiting each side is waiting for each other to do the next thing, right? So the application starts, connects to the database server, so the database server is waiting for the query to show up. Then the query shows up, and then the database server sends it back, and now the application does something with it, right? So every single database system will implement its own wire protocol. We don't need to discuss that in this class here. That'll be in the advanced class. And then the client-side APIs we would use to communicate with the database server is JDBC or ODBC are the standard approaches. So just to show again what this looks like. Say this is your application server. It's running somewhere. It's running in the cloud, dedicated server on the same machine. Doesn't matter. But when the application starts, it begins a transaction. It executes some queries. That goes over the wire. The database server then has to take that SQL query, parse it, plan it, optimize it, then actually run it. Right? All the things that we've talked about in this semester so far. And then it sends back the result. And then now, assuming this is done in the context of a transaction, now the database server has to sit and wait for the next command, right? Because the application server is going to take the result that it got back for that SQL query and now do something with it. Right? It can have if statements to say, here's the next query I really want. Maybe it wants to abort the transaction. The data set doesn't know, doesn't care, but it's sitting and waiting. Then we get the next query. Again, it goes over the network. We have to do the same thing, parse it, plan, optimize, and run it, send the result back, and then we wait. And then eventually it does some more processing. We're still waiting. And finally we get down here to commit, and we tell it to go to commit. Right? So there's a lot of round trips here. I'm not saying whether it's on the same box or the network or the same rack. It doesn't matter. But still, it has to communicate to say, hey, do these things, and then each side is waiting for the other one to respond. So the goal for us today is to figure out what logic we would have over here can we actually push into the database server. Because it's sort of related to that, like pushing the query to the data versus pulling the data to the query. We want to be able to maybe push as much logic as we can directly down to the database system and have that be able to take actions or do certain things without having to go back to the application and ask for the next command or what to do. So we're going to get several potential benefits by pushing this logic into the server. And I'm putting the word potential in here because there'll be some cases where we'll see some downsides where if we do use certain things like a UDF, then the query could actually get way worse. And we'll understand why. So I've already said this, we'll have fewer network round trips because we just sort of try to push as much in a single query, a single request to the database server and make that do as much work as possible for that request. We'll have more immediate notification of changes because the database server will be there when the change occurs, and we can define some action or something for it to do when it sees a change. We talked about how the database systems can spend less time waiting for transactions, waiting for the next query. This is important. Again, on two-phase locking, I'm holding those locks potentially when I send back the result and waiting for the next query. So if I can reduce the network round trips and reduce the amount of time to get the next query or receive the commit command, then transactions will run more quickly. And then the last one is more fuzzy, but it has to do with sort of software engineering idea, where if we can have some core logic in our application now embedded inside of the database system and have the database system maintain this for us, then it doesn't matter if we end up rewriting the application or make different versions of it. We don't have to re-implement that logic over and over again for different applications, right? The database system can just handle it all for us. So, like, say if I had a desktop application for a desktop version of my application, and then I want to make a mobile phone version. Maybe the desktop one is written in, I don't know, C#, whatever people write, Java, but then the phone one's written in Swift or whatever Android is, Java, I guess. Like, if I have to have the same, there's some important logic that those two different applications have to both implement. If I can put it into the database server and have it just be the single implementation, then I don't worry about having bugs when I try to port it to different languages or different environments, right? So it's going to be, again, a high-level overview of a bunch of different methods that people use to embed database logic. UDFs, or user-defined functions, are going to be the most common one that you're going to see in the real world. Store procedures are much less common. Actually, UDFs plus triggers are probably those two are going to be the most common. Change notifications, user-defined types, and then views. And then we'll do some demos today. Actually, all the demos are going to be in Postgres because it's going to support all of these, and I know the syntax much better than all the other ones. It's much more friendly. Okay? All right, so user-defined functions, the UDFs. The idea here is that we want to be able to extend the database system's functionality to go beyond the functions or the capabilities that it has out of the box. So I think I might have said this in the beginning of the semester that when we talked about like string functions and date functions, right, there's a SQL standard that says here's a bunch of built-in functions that a database system that supports SQL has to have. But obviously, if your application has something that's very specific that you need done, there might not be a built-in function that does that. So you can write your own functions and embed them inside the database system, and then they'll be treated as if it was like string length or concat or like a built-in function, and you call them directly in your SQL statements. So it's a function, right? It's pretty basic, right? You take in some kind of input arguments, typically scalars. You do some kind of computation, and then you're going to return back a result, and that result can either be more scalars or other tables. So the computational part can have all the sort of imperative constructs that you'd expect in other programming languages, which are not really easily or not really defined in SQL. You could have if clauses, for loops, throws exceptions, make calls to other functions, and so forth. And so we want to do this because, again, there'll be some logic that's going to be difficult for us to express cleanly in SQL, whereas writing into an imperative language will be much easier. So when we define our UDF, again, you basically have the return types, and again, it's either be returning a single value or a single result table or set of rows. And then the definition of the function itself, the thing that actually does the computation, could either be a SQL function, meaning it's just a bunch of SQL queries without any deep logic, or it could be an external programming language, an additional programming language that isn't SQL. So we're going to go through the SQL functions first, because that's probably the most common. And this is the ones that's actually the most supported in systems. And then we'll look at the additional programming languages. So a SQL-based UDF is just a list of queries that the data system is going to execute in the order that they're specified. And then whatever the last query in the UDF, whatever it is, that's just the return value. Right? So we have this create function now, command in SQL. So we call create function. We specify that this is the name of the function, get foo. We'll define some input arguments. We have a return type. In this case here, we're going to say returns foo because the last query is going to be returning from foo, or the last query will be a select on foo. And then we have the actual function body itself. So when we invoke this function, we pass in some parameter as int, and we can reference it with $1. So in this case here, this function can be invoked either in the output list of a select query or in a from clause. Because it returns back a row or a table, for this type of query or UDF, you can't reference it in the where clause. Pretty basic, right?
What is the $?
Yes, the question is, what is the $$ sign? This is just saying that this is the body of the function. And in this case here, I think for Postgres, it treats this basically as a string. I think it does, actually, I take it back. It does some parsing because it knows that it's SQL, so it assumes that it's just going to, everything that comes after it is going to be SQL statements, and it'll actually parse it. We'll see when you use other UDF languages, it's just a benign string and it doesn't do any parsing until you actually run it. So again, pretty straightforward. Let's do some live demos. That's always fun. All right, so first thing we're going to do is going to define our table, foo. All right, I'm going to move this over here. Right. And then we're going to put some data in here. Right, click select star from foo. Right, nothing special there. And then now we're going to define our function. Awesome. Oh, because I'm missing the $sign. Sorry. That's a bummer if I broke this already. Sorry. I did. There we go. All right. So now I can call select, as I showed before, I can call select get from foo in just in the query in the front. Move this down. Right. In this case here, it's returning back me a tuple as a single column with a tuple in it. But if I put it in the from clause, since it knows it's returning a table, right, then you actually get the columns, right? So far, so good. So pretty easy, right? Nothing fancy. All right. So the SQL standard also provides an atomic keyword, which may seem kind of confusing, like oh, does this mean this is a transaction? No. So what atomic provides means that it's the database system is going to track dependencies between the SQL queries that are defined here in the UDFs, similar to like when you have a foreign key, so that if I try to drop a function that references another function, sorry, if I drop a function that's being referenced by another function, right, it would know that it can't do that and would prevent you from deleting this, right? So there's a way for the database system to provide some additional functionality about, for making better for developers, so that like you're not the same protections we would have for referential integrity in tables, we could also have it in our functions. It's a quick demo of that one. Okay, so what we're going to do is we're going to create 3 functions, A, B, C. Dropping them just to make sure they exist. So all they're going to do right, here's A at the top, all it takes in is an integer, and it's going to multiply by 3. B is going to take in another integer and call A and multiply that by 2, and then C is just going to call B, right? So there's a 3-way dependency, or so the dependency between C depends on B and B depends on A. So again, it's just nothing's fancy. I can just call select C1, and I get back a result, right? So now what I'm going to do, I'm going to drop A and C, but not B, right? And so when I created these functions, I didn't use that atomic keyword, so it doesn't, the data set is not trying to figure out, okay, what depends on what for these different functions. But now if I go back and try to add C, which is going to call B, right, I can do that. Even though B calls A, but it since it didn't track dependencies, it doesn't know that, at this point here, it doesn't know that A is missing or doesn't care, right? And I'm allowed to create the function. But if I call it again, right, it'll crap out because, when C calls B, B then tries to call A, and it doesn't exist, right? So let's drop all the functions again. And then we're going to add them all back, but this time we're going to use the atomic keyword, right? So again, I define a function C, tells the language is SQL, begin atomic, and then there's the body there. So now when I go to try to drop A, it's going to throw an error because it knows that something depends on it, right? It knows that B is calling it. So it doesn't let you do that. So to handle that, just like again when foreign keys, we can add this cascade modifier to our drop clause so that we're going to drop A, and then it's going to cascade the drop to any function that references it to avoid a dangling pointer. Yes?
Why didn't this feature the default?
The question is, why isn't the feature the default? Good question. Postgres just added this like 2 or 3 years ago, so it's not. I think it has to do with that they're trying to do lazy parsing of the functions. That you just define it as a string, put it into the catalog, and then only at runtime when you go to actually invoke it, then you start interpreting it. I think that's the reason. Okay. Nothing fancy here so far, right? All right. So the SQL, the SQL functions, they are, you can almost think of like a macro, right? That you could copy and paste a bunch of SQL queries and put it into a single function. But again, you're still limited to the type of logic you can represent and defined in the SQL function. It's limited to whatever SQL supports. And so some database systems will also support writing UDFs in additional languages that go beyond SQL and can be procedural or imperative. So the SQL standard defines that a UDF language, the UDF language in the SQL standard is called SQL PSM. It's like SQL Persistent Stored Module. It's some 1990s enterprise technology. Always has crappy names. So the SQL standard defines a programming language called SQL PSM. Nobody actually implements that, right? Everybody has their own. Oracle's PL SQL probably looks the closest to SQL PSM. Postgres has PL PG SQL, which is their variant of Oracle's PL SQL. MySQL doesn't support any of these. You have to write your things in C or SQL functions. But then SQL Server and Sybase support this other UDF language called Transact SQL. Out of curiosity, who here has written T-SQL before? No one. Okay. SQL Server is a good system. SQL Server is a solid database system. The history, again, of SQL Server is that Microsoft didn't make it from scratch. Microsoft bought a license to Sybase in early 1990s to port it to Windows NT. And then they had in that contract, they were allowed to do something with, muck around with the source code. And they ended up doing a hard fork in the mid 90s and hired the guy that built did that volcano model stuff we talked about before. They hired him and a bunch of other smart people, a lot of them at University of Wisconsin, because that's a database powerhouse school. And they rewrote SQL Server entirely. And now Sybase got bought by SAP. It's more or less in maintenance mode, whereas SQL Server is a state-of-the-art system. So they were together, and then they diverged, and SQL Server, I think, has surpassed them in capabilities. But anyway, Sybase had their own thing called T-SQL back in the 1980s, before the SQL standard came out. It looks similar, but you'll see some dialect differences. But that's why historically they support their own thing, transact SQL. You'll see this in a second. The language is going to look a lot like Ada. Has anybody's heard of that? Nobody? He's waving his hand. You're European, so maybe, I don't know. It looks like Pascal, if you ever heard of Pascal, right? Because the guy that was on the defined the standard, he was really big into Ada. So that's why it looks like this. So other systems that support additional programming languages that are more, I don't say more traditional, more common. Like in Postgres, you can write UDFs in Python and Perl, maybe Java, definitely in C. And some of these languages will be safe enough that you could run them directly inside the database system. Actually, Amazon put out something yesterday. I haven't looked at it. They have their own, they have their trusted language extensions for Postgres. That's like Python and Perl. So it's a way to write Python UDFs and other functionality to extend Postgres, but then still be able to run it in Amazon's hosted environment, right? Because the issue is going to be if we write my UDF in C, what can you do in C? What's that? Well, I mean, the answer is everything, anything, right? Like, if you can write a UDF in C, you can malloc or do whatever you want, write to any arbitrary location in memory. So in some systems that like in Oracle, you can write your UDF in C, but they'll run you in a sandbox in a separate like process that's isolated from the main database server, and you have to use like a IPC command to send data back and forth between one process to the other. Because what they don't want is you don't want your stupid C program to like start trashing the memory heap and crashing the database server and corrupting data. So they'll run you in a sandbox. Postgres does not. Postgres, if you write a extension or you write a UDF in C, compile to a shared object, you can link it in and then do whatever you want, right? So anyway, there's other programming languages other than the ones up here. We're going to focus on the ones up here, but like they have there'll be some standard API that the database system provides for you for the different bindings for the different languages, right? All right. So let's look at a PLPG SQL example in Postgres. So now we see here that we have defining that same function we had before, get foo, but now in our return, it's going to return a set of foo, and then the language is specified here is now PLGB SQL. And to his question again earlier, the double dollar sign just means like here's the body of the function, and you can treat it as a giant string. Yes. What's the return set of foo? It just means that you're getting tuples of foo. So it would know that the return type is going to be the same schema. It's going to be a set of tuples that have the same schema as the foo table. Right? So in this case here now, instead of just having implicitly the last query of the function being the return value, I have to now specify that here's the return clause, and it's going to be a query you invoke the query here. One nasty thing you can do in PL SQL or PLPG SQL is you can actually concatenate strings together and like define a SQL statement that way, as a string builder, and then invoke the query. Right now you see why it's kind of hard where you can't actually maybe parse the UDF when it's instantiated like you could with a SQL statement or SQL function, because you actually have to execute the code to actually maybe figure out what query is actually going to execute. And again, there could be if clauses, could be conditionals where the query that it's going to get generated might be different versus one pass versus another, because it depends on the state of the database system. All right, so let's look at a more complicated example. So the next one is now just going to do a summation. So first thing to point out again, because this is inspired by Ada. It's the 1980s. You have to define your variables before your function, right? So you declare them at the top here. You tell them what they are. So the foo record is going to be a record, and then out will just be an integer. And then now in my my body, now I have a for loop where I'm going to loop over every record from foo that comes out of this select statement here. And all I'm doing is just taking the counter and adding whatever this integer value to it. And I return that. So let's see how it works. So, right, just create the function like before. So now I can do things like select star from some foo, and I'll pass in 1. Right, it gives some value like that. Right, so when I call this function now, the function gets invoked, and then inside that function, it then invokes another query. So it's almost like a nested query in some ways. Right, or again, I can put it out. This one here, since this returns a, going back to my definition, since I'm defining that the return type is an integer, I can now start using this in the where clause because it returns a scalar. Even though what the computation actually is doesn't matter, but I can start doing where ID less than some foo 1 like that, right? I can even start putting in here some foo ID, right? Yes.
So what would be the difference between this and nested SQL query?
His question is, what would be the difference between this and a nested SQL query? There's 2 ways to think about it, from the database system perspective and then from the application developer's perspective, right? From the database system's perspective, it's actually worse because the UDF is a black box, right? If I call explain on this, all you see is that it did a sequential scan on foo, right? And then inside this filter, there's this some foo clause invocation here. So the optimizer didn't try to figure out, okay, what's actually some foo doing? Oh, there's another query inside of that. Maybe I can lift that out and use that as a nested query, and then run all my optimizer tricks that we talked about before. So this is a common problem in UDFs, which we'll get in a few more slides, is that although my example here, the logic is pretty simple, as I was saying before, you don't actually know what it's going to do until you actually run it. And then the execution path of the UDF is going to depend on both the input parameters and the state of the database, because I can make arbitrary queries to the state of the database. So from the application developer perspective, it's potentially better because, again, there might be some logic that is, again, traditionally more easier to implement using UDFs. Okay. All right, so this actually summarizes much stuff I've already said. So what are the benefits of UDFs? So it's gonna allow developers to be able to potentially reuse, again, complex logic across different implementations of the application. So again, if I have a mobile phone app and then the web app, I don't have to re-implement maybe real complex things in the different languages. I can have one express it once inside the database server and reuse it everywhere. For complex operations, it's also going to reduce the number of round trips because I don't have to go back to the application and figure out the next thing to do. I can push things to the database server. And then the last one, as I already said, some things are easier to express and read in UDFs. But now, what are the bad side, right? So the first one I've already said. Most query optimizers, with the exception of one, and I'll say who it is in a second, almost every single query optimizer is going to treat the UDF as a black box. Doesn't know what's inside of it, doesn't know what any queries it's going to evoke, right? And therefore, it's not going to be able to make estimates about the selectivity or the cardinality of expressions in our where clauses or our join clauses because it's a black box. Right? I never said that was a big deal for the query optimizer. You'd want to know, if something equals something or something less than something, you want to know what the selectivity is going to be, because that's going to help define how many tuples are going to be pushing up in different parts of the query plan. So then I can figure out what the join order, the most optimal join order is. So because I want to filter out things sooner rather than later. But again, if it's a black box, if it's some imperative language, right? If it's C, I mean, all bets are off. Who knows, right? But even if it's PL SQL, PLPG SQL, the system's just not going to know. The other challenge is going to be that when things are correlated inside of the UDF, that you're not going to be able to easily parallelize them. There are some systems, the names, which ones escape me now, but Postgres got better at this. But some systems used to, that anytime you had a query that had a UDF in it, because you don't know what's inside the UDF, you would default to run it as a single thread. Because you maybe don't know the ordering of, like there could be maybe updates inside of it. You can put anything. Now there are some, in case of Postgres, you can pass in hints. You can say, I know this UDF is parallelizable, or I know this UDF is immutable. SQL Server will restrict you that only UDFs have to be immutable. Stored procedures, which are another type of functions, they can update things. But Postgres lets you do anything. And then the other challenge is that if you have, as I was saying, some UDFs where they're concatenating a bunch of strings together and then invoke a query, again, you don't know what that's going to be before you start running it. So it's hard to be able to optimize that. The other one is a bit more nuanced, is to say that when you have UDFs and the select and where clauses, that you're not going to be able to take advantage of all the sort of the tricks we can do in our database server, our database system during query execution to like batch things together to speed things up. Right, we talked about vectorized execution. Sorry, yes. Okay, like in some systems, when you see a UDF, since you don't know what's going to do, you got to invoke it for each row by row by itself. And because the UDF itself is going to be defined, for the most part, to operate on a single row. But maybe what you really want to do, a better way to do this is take a batch of tuples, or all the tuples that I'm passing off, from one operator to the next, and pass that in as a single invocation into the UDF. Have it do all its, whatever it needs to do on the batch of tuples, and then complete. Because that's going to be way more efficient than calling individual selects or updates one row at a time.
So if, like, in C++ or something like doing some style, does it typically database of document manager? Does it use differential?
So his question is okay. His question is if it's written in C, and does it use what memory is it using? Well, I mean, if you call malloc inside the C function, it's whatever the OS is going to give you, right? But like for immediate results, actually, during query execution, it'll go to the database server. So we do all the standard buffer pool stuff we've done before. But like when I get back my result, it's going to be, I have to copy it into my process, so I'm going to have to malloc for that. Yeah, the fact that C doesn't matter. Same thing with PLPG SQL. I don't think like when Postgres is running this, if you have a variable, it's just sitting in work memory. It's not actually backed by the buffer pool. Right. So again, because we're executing everything in the UDF one by one, there may be actually situations where in my UDF I call two queries, one after another, and I could potentially could have run them together, like combine them together automatically, so that it becomes one query. But again, I can't do that because again I don't know what's on the inside. So I would say there's been attempts, or there's been some extensions to UDFs, maybe like in SingleStore or MemSQL, they had their own version of a UDF language called MPL. I don't know what it's called now, but like it had constructs to like you could define parallel functions in your UDFs. SQL Server has tried compiling the UDFs into like the native language, like JITting it and seeing that speeds things up. It does make the UDFs run faster, but it doesn't solve that black box problem that I talked about before. Yes?
If they're just macros, why doesn't the DBMS just take the code out and optimize?
Okay, so his question is, he's correct. Well, no, hold on. So if they're SQL functions, then you could potentially do some pre-optimization on those and like store it as prepare statements. But if it's the imperative language like PLPG,
I meant like the SQL implementation.
why not just take this out and I don't. What's that? Yeah, I mean, but it's no different than a CTE. So here, make sure I do this right. So his question is again, if it's a SQL function, which I think my get foo is, right? Actually, let me start it over. Make sure. So if it's a SQL function, why not just drop it in like a macro and let it optimize it as before? Or sorry, like have it all be inline and optimized. So let's see. So if I call explain select get foo 1, that doesn't tell me anything. Yeah, it's not. So in this case here, it looks like Postgres is not being smart enough to know that get foo is only one query up here. You can't see that. Get foo is only one query. So in theory, like I should be able to see. I would expect it to, when I call explain like that, to see this. Right? If it was actually planning right there, you would see the index scan in the explain output. In this case here, it's a function scan called get foo. So I think it's gonna parse it and it's gonna optimize it at runtime. And
there's no obvious reason why it doesn't do that, right?
Question is, there's no obvious reason why it doesn't do that. It looks like Postgres doesn't do anything. Well, again, if I have multiple SQL functions SQL queries in my SQL function, then you actually can't just plop it down inline at one, right? Like I could do this. Let's see if we can put this in an infinite loop. So let's do insert into foo.
Because the language used for implementing functions is not like it's more than just normal SQL, right?
The question is, the language used for UDFs more than just SQL?
Yeah.
So I mean, if you define it as a SQL function, it has to just be SQL statements, one after another. You can't have like if clauses. Like if it's PLBG SQL, then you can put if clauses. All right, so in this case here, I'm going to call insert, and then I'm going to call then do the select. And again, the output should be whatever the last query is. So now if I run it, let's see. Sorry. I want to run this one. Right, I get the one out. I get the output I expected to get before, but now if I look at my foo table, I see the insert called, right? So in that case, it's not like a macro just plop it in. If it's one query, yes. Otherwise, no. So this is also running in the context of a transaction, right? So it's basically, again, just think of it like you sort of pause the query, the outer query that invokes the UDF. Put that context aside, then invoke whatever queries you see inside the UDF, and any of those queries fail, then the whole transaction fails. So in this case here, this should fail now because the ID field is the primary key, right? And I try to insert in my UDF a duplicate key. And then now my transactions roll back, right? Yep. Okay?
When Postgres executes the UDF, does it run query optimizer within that UDF? Like your UDF example, if you add an explain statement before the select,
Oh, this question is, if I put explain before the UDF, what will happen?
inside the UDF.
Yeah, I understand. Yeah, let's see what happens. So let's get rid of the insert. But actually, that right there, that tells you that I tried to drop the function, but I was still in an aborted transaction. That shows you that Postgres treats catalog updates, like creating function, dropping function. You can do it in the context. Those are transactional, so it didn't let me do that, which is cool. But you want that. All right, so now I'm doing what he suggested before, where I want to put explain inside of it and see what happens. Didn't like it. Okay, so let's try this with the. So I'm going to put the explain first, and then run the query. Let's see what happens. I think the explain is just going to get ignored. Yeah. Yeah. So
We don't know what happens inside.
you don't know what happens inside, which again, we'll get to this in a second. How to debug these is a pain in the ass. All right. So I'm going to show one example here of how bad actually things can get with UDFs. We treat it like a black box. So this is from a paper we'll cover in the advanced class where they took TPCH, which is the standard analytical OLAP benchmark people use for database systems, and it's a three-way join between orders, line item, and customers. Think it's like you're tracking what items people are buying, and line item is the fact table we talked about before. So they did the join as a UDF for the customer name, for the customer. And all you're doing is looking up, make sure, does the customer actually exist, right? And so the scale factor of this is 1. So in TPCH parlance, that means the database is 1 gigabyte in size. Right? It's not that big. So the UDF looks like this. All you're doing is you're taking in the customer key as an integer, and then you're going to evoke it and then return the name. As long as that name is not null, then this returns true. So if you write it just pure SQL, the original query, right, it'll complete in less than a second. If you just change just this one AND clause to now be a UDF, it takes 13 hours. Right? Or 13 hours, 30 minutes, almost 14 hours. Right? Because again, the data system doesn't know anything about the customer name. Doesn't know about this UDF, and doesn't know that it can do this join in parallel. So for every single row in the line item, it invokes this function over and over and over again. Right? Whereas if I was basically inlining the select query as part of the join here, then I wouldn't have that context switch of going invoking this UDF and invoking this query every single time over and over again. So it's so bad, Microsoft actually, they acknowledge that their functions are terrible and bad. And it's not, again, not specific to Microsoft. It's just the nature of UDFs, because they are opaque. You don't know what's going on. The optimizer makes bad choices, right? And so there's a lot of blog articles that talk about how these things are evil and don't use them. And so what we'll cover in the advanced class is the thing that sort of what he was alluding to is Microsoft has a technique where you parse this, you can actually convert it to relational algebra, and then you inline it back into the query plan of the outer query, and then you just run all your optimizer tricks as before. Right? So it's called Freud. Actually, well, the research paper is called Freud. It's very impressive. They have patents. Nobody else does this. But to me, it's one of the best ideas in databases in the last 10 years. Okay. So similar to UDFs are called stored procedures. Again, these are going to be less common. But the difference is going to be all the UDFs we showed before, they have to be attached to some query. Right? You have to invoke them as part of a select statement or update statement or some kind of SQL query. Right? But with the UDF, it's almost like an RPC construct where I have this function, I can just call it without having to invoke it inside of a query, right? So some systems, actually Postgres used to do this. They didn't have a distinction between UDFs and procedures. Newer versions do, where you have to declare something either a procedure or a function, right? And then, like I said, in case of SQL Server, if you declare it as a procedure, you can update the database or update tables. You can do anything. If it's a function, then it has to be read-only. So the basic idea is here. Here's that application we had before. It's a bunch of SQL queries intermixed with program logic. We just take this thing, embed it inside the database server, and then now our application only invokes the call command and invokes the stored procedure and gets the result. So no network round trips. Yes. This question is, functions are typically written in SQL, just SQL commands. So I mean invoked in SQL or written in SQL?
I guess the example that we saw pretty much is SQL.
No, I showed a PLBG SQL example, the summation. That was arbitrary logic. Oh. Yeah. These will actually, I think you could probably write these as just with the SQL commands, SQL queries. I guess you could. I don't know. So, but no, I mean, like in the UDFs, you could be PLPG SQL. It could be C, it could be Python, it could be any of the languages. All right, I hate showing code in class, but it's unavoidable here. So I apologize. All right, so this is a more complex example of doing a procedure now. And this is the example I showed at the very beginning when we talked about transactions. Taking money out of somebody's account, or checking whether somebody has enough money. If they do, then take money out of their account and put it into another account, right? So you see here that we're doing a select now, and we have this into command here, or these modifiers, where that's going to tell it to take the output of the select statement and then store that in these variables we defined up above. Then we have an if clause to see whether this person has enough money. If they don't, then we raise an exception. It's basically a way to throw an error and say that this thing can't complete. And then afterwards we do the updates on the accounts, balances, and we commit. Right? And again, if I had to do this with sort of client-side code, it would be one round trip to do the select, then the application code checks this balance, then it's another round trip to do the update to take the money out, then another round trip to put the money back in. But I can do this again as a single procedure call. All right, so let's quick example. So I'm going to create our accounts table. Right, I'll put your money in and three fingers, and then I'll create my procedure. Right, just as before. So now I can call. Well, okay. How much does he owe you? God. You got TAs don't get paid that much. DJs don't get paid that much. All right. So what's that? So now I can call transfer. So I'm going to take money out of Mushu's, put it into three fingers, and we'll send him $50. Right? And then now I can do a select, start from accounts, and we see we transfer the money. Right? And of course I had the conditional logic that says if he doesn't have enough money, so we try to send $1,000, it throws an exception. Mushu does not have enough money. Right? Okay. Right, and here's just the invocation with call. So I've already said a lot of this before, but the UDF is meant to be some subset of a read-only computation within a query. I think Postgres restricts you to be read-only now. They didn't used to be. And then whereas a stored procedure is meant to be some more complete transaction. Like when we talked about before, like the idea of a transaction was this high-level operation that the application wants to perform, like take money out of account, put it in another, multi-step. That's what a stored procedure is good for. Yes.
It seems like basically the stored procedure, I mean the UDFs and stored procedures together is like basically you can do anything.
Yes.
With data on the database.
Yes.
So why are that like why you even need some sort of like server? Like, is there anyone who attempted to just write server code on the database itself? Then you can like cut away any of the application code because you're basically writing application code on.
So the statement is, if we can use stored procedures in UDFs to put complex logic into a database server, why even bother write application code?
Right. Like then you just have.
Who here has written PL SQL before? Nobody, right? We'll get the end. I mean, it's actually a good question. Why don't people use this more? I mean, one of those obvious things I have to say out of the box is because that code sucks, right? It's in this 1980s style, like all the sort of the nice things you want to have in a modern programming language, these things don't have, right? But there's some other reasons we can get to the end. Yes.
Here it says the UDFs are read only, but didn't you have the UDF with like search statement?
Yeah, so it's meant to be read only.
It's not enforced.
No, well, SQL Server enforces it. Postgres does not. Yeah. Another question over here. Okay. Yeah, sorry.
But it doesn't have to be in the official language, right? Like you said, it's 4500.
Sure. Okay, so let's hold off on this. I want to get through other stuff, and then I've already said some of the reasons why people don't do this, but there's other things we can get to. Yeah. All right. So now one thing we can use UDF for is that is super important and actually is very common is to do triggers. So trigger is a way to tell a data system to do some action when some event occurs inside the database system, specifically for data on tables. So if you want to use a trigger, you're going to have to define what type of the event that you wanted to cause the trigger to get fired. You have to specify what the scope of the event is, and we'll describe that in a second. And then we define when the trigger is getting invoked relative to the event. So an easy way to think about this is, say I want to have a trigger that anytime somebody deletes a tuple, I want to fire a UDF on fire trigger. But do I want that UDF to be fired before the tuple gets deleted or after? And should it get fired for each individual tuple or for the batch of the tuples? So let's do a really simple example here. So we have this table foo, has an ID and some kind of value. And so what I'm going to want to do is I want to maintain a separate table that's going to keep track of all the values that got overwritten in my main table foo. Right? Think of like I'm using this for auditing, right? To keep track of like if someone updates a record, since we're overwriting the original value, I want to keep track automatically what the old value was. So I'll make this audit table that's just going to have some kind of ID field. It'll have a foreign key reference to this ID here, and I'll keep track of the old value that got overwritten, and then the timestamp of when that thing got changed. And then I'll define a UDF that will get invoked anytime the foo table gets changed. And so now we can see here that we're passing in, we have these implicit variables called new and old, and that'll be the new value that's going to get updated, that's getting installed, and then the old value of the tuple. So it's a reference to the tuple of the previous and the new. And then I'll again just take that, insert it into my audit table, and then return the new one. So now to set up this trigger, I'm going to call the create trigger command to install it, and I'm going to specify that I want to fire this trigger before the update occurs for each row that's getting updated, and then I want you to invoke my log foo updates, my UDF I defined above. So this is actually a very, very common scenario, application scenario, that you do automatic auditing, right? So let's see this. So first thing we'll do, we're going to create our foo audit table, and then we're going to create our UDF. And again, the main thing here is that there's this new and this old. You see, they're not getting passed in. It's implicitly available for me in the function, right? Because the return type is trigger, so the system knows that okay, you expect to look for new and old.
Are new and old part of SQL standard?
The question is new and old part of SQL standard. As far as I know, yes. And then I'm going to find my trigger. And then so now if I look at my table foo. Right, so let's do update foo set val equals YYY, where ID equals 4. Right, so now if I go back to my foo table, I see ID 4 has been set to YYY. But if I look at my audit table now, right, you can see that it automatically created an entry for me with the timestamp and the old value, and then the reference to the primary key in the table that got modified. Yes?
So if the original update statement failed because transaction reported, does this internal one also get reported?
His question is, and again, the question is how does the trigger interact with the transaction and maybe the outer query? They call it the trigger to get fired. It's all together, right? It's all it's equivalent as if I was executing the first query, then executing manually the second query, right? Just because it's a trigger doesn't mean you lose. It's done outside of the context of the transaction. So I can see that here. So I can do begin. So we'll start a transaction. And so the question is like, I gotta think, what can I violate here? Yeah. So I'll update this now to like that. So again, I look into foo. I see that's been updated. Audit. That's been updated. But now I roll back. And my audit entry is gone. Right? What?
No, but things that isn't application code kind of like how do you know how can you just roll back on trigger?
How can a data system roll back in the trigger?
Wait, is a trigger okay? The trigger is something that is like somewhat like a user-defined function.
It is a user-defined function that's embedded inside the database system that you attach to an event and say,
But how would they know what is modified? Like
who's they?
How do you know what to roll? Like how do you know because the user-defined function like the trigger is what inserted the YYY into the full audit table.
Yes.
But how do they know exactly what to like roll back?
Your question is, how does the data system know what to roll back from a user-defined function? Because the user-defined function, if I go back to my, like the definition of it, it's making a SQL command. It's calling insert, right? So it knows what you did because it had to do it, right? So like in order to do what the thing it needed to do, it needed to know what it did. So again, it's just me. It's the point I'm trying to make is like the application. It's like it's all embedded in the server side where I don't have to have something else polling. Or sorry, I don't have to write my application code. Oh, I know I'm updating this table, so let me also insert into this audit table. The database system does everything for you. Yes.
Are you saying this is done at runtime when you actually run the function? It records that I did another insert in audit, and that's how it knows because.
So your statement is like when I updated the table, the query plan has basic checks to say, okay, do I have any in my query plan when I'm about to update something? Are there any triggers attached to this table for the update? And
I'm sorry, I was still talking about the rollback because
the rollback is you know the right set of the transaction. You know what it inserted.
okay.
Right? And then when the transaction aborts, you say, okay, well, it doesn't actually know or care that it inserted something to foo audit because of a trigger. It just knows I put something to foo audit that shouldn't be there anymore. Yes?
Could you write UDFs that have side effects like sending an email?
This question is, can you write UDFs that have side effects like sending email? Yes. Should you? No. We talked about this before. Like you can do it, but if the transaction rolls back after after the email's been sent out, you can try to be like an old person using Outlook and try to retract the email, but that's, like nobody does that, right? Like it's not going to work. Once something leaves the purview of the confines of the data system, nothing we can do. Yes.
Is there any way to put like a trigger on after commit?
Okay, next slide. So, what are the events we can attach ourselves triggers to? So insert, update, delete, truncate, which is just dropping a table, like a delete without a where clause. We on creates, alters, and drops. The scope could be what are we looking for the event, right? So the triggers I'm showing now are table triggers. Like when something happens to this table, do something, right? But you could have it for the entire database. You could have one for the system itself. And then when the trigger gets fired, it could be either before the query executes, after it executes, before after each row gets modified. And then there are some systems, I forget who does this, where it's almost like a rewrite rule where like you invoke a query that has a trigger attached, and the data system will replace that entire query with whatever the trigger function is. Yes?
Can you like create like so? But it definitely do not do like loop detection, right? Like can you create a like trigger that on create a table, you drop a table, but create a table.
So the question is, can you get stuck in an infinite loop? Yes, let's do it. I would say that I know that like a UDF can call another UDF, and I know that you can have basically there's like a counter say how many layers are you down into it, and then they'll kill you.
Okay, so they do kill you. It's like a
Yeah. So let's do this. Let's attach a function, or let's attach a trigger to foo audit. That. Let's see, what do we want to do? Let's attach a trigger to foo audit that then inserts into or updates into foo, which then would calls a trigger into foo audit. So let's do this. Let's call this bad idea. So we don't need the old and new. We're just always going to insert into, no, it has to be an update, right? So update foo set val equals val Andy, where ID equals 1. Actually, we can do old.id. That should work. Return new. Oh shit. Yep. Yep. Okay. So now I have a trigger. I have to attach it now. So now create trigger. Trigger bad on update, or sorry, before, after insert on foo audit for each row execute procedure, and I said it's about bad idea. All right, so now this should put us in an infinite loop. Make sure I'm not in a transit. No, I'm not. Let's do it. Huh, okay, so what happened? That didn't get fired. All right, so I bet it's new. What's that? So we got to drop the trigger. Hold up. How do you drop a trigger then?
Is it because you didn't update instead of insert?
I guess we can do.
The trigger is on insert.
Before. All right, let it rip.
This is a lot of work to demonstrate an infinite loop.
What's that?
This is a lot of work to demonstrate an infinite loop.
Yeah. The answer is, I think yes. I know you can. I don't know what's going on here. Actually, did it actually?
Should you change the trigger to be like for update instead of the
No, because you're inserting into foo audit, not updating. So I want to trigger on foo when I insert into foo audit. Yeah, I don't know. Screw it. All right, you can do it. I don't know how to do it. It's hard to do it live. Okay, we still have a lot we want to cover too. Okay. All right, so the next thing we can do is do change notifications. And this, so the trigger we showed about before, that's still all inside the database system, right? And so I can, with the trigger, if I had to write, without the trigger, I had to write application code that would pull the database server, maybe that table over and over again to see whether there ever a change, and then put something in the audit log, or write my application code to put things in the audit log. But it's still all done on with the trigger, the notification of what happened, what changed, is still embedded inside the database server. So in the SQL standard, you can have these change notification constructs or commands that allow the database system to tell the outside world that something has happened inside the database system. And again, to his point before, like, can I write a UDF that sends an email? Yes. Don't. Like, you could still get something similar in the construct of SQL. And so think of this like a pub sub system, right? I can subscribe to a channel that says, give me updates when they occur, right? And in the SQL standard, it'd be listen and notify. So this is all pure at this point. Like, well, listen and notify is in the SQL standard. What I'm showing here is purely Postgres only, right? Because we're using Postgres specific functions. So this is going to be a function now called notify foo updates that we're going to treat as a trigger. But inside my trigger function body, I'm going to take the row that just got updated. There's a Postgres function called row to JSON. It basically takes the row, turns it into a JSON document, store that in a string or a JSON string, and then I'm going to call this thing called PG notify that's going to invoke convert the JSON object into a JSON text or serialized to text, and then call on foo update, which would be the name of the channel we're going to attach to. And then I define a trigger that says anytime I insert into the audit table for each row, I'm going to invoke that function, invoke that procedure. All right, so let's try this live. So again, first thing I'm going to do is create my function, just like before. Then I'm going to attach a trigger. And then on the terminal at the bottom here, which I think, make sure I'm still connected. So the terminal on the bottom, it's going to listen on foo update. And then my terminal at the top is going to invoke query, updates the table. And then the one on the bottom, if I call now select one again, now I get a notification of here's the change that occurred. Way more than I thought you were going to get, actually. Why? Oh, so sorry, because the SQL query is where ID doesn't equal 1. I missed the not, right? So this is updating all of them. So at the bottom, you're getting, we got a bunch of these notifications, and then you can see the payload is the JSON string of the tuple, right? So the reason why I had to call select one is because it's asynchronous. The pSQL terminal here is not polling the database server over and over again to say, hey, do you have any updates for me? There are client-side APIs or libraries that will do that for you, so that you can get the notification later on. Again, this is just a way to push updates outside the database server. Okay. So the next thing to talk about is how can we start representing more complex data types in the database server. And again, because we want to avoid having to have application code that maybe knows how to pick apart a JSON document, right? Or do have some additional logic to parse a blob that we're storing in the database server, right? So there may be, oftentimes in applications, there's a complex data type that you want to represent atomically, or as not a scalar, but yeah, atomically inside the database server, so that all your different implementations of the application that can connect to it and reuse that type without having, again, the custom code to handle it. Right, so let's say that I want to keep track of coordinates. I have a coordinate type, x coordinate, y coordinate, and then some kind of string label here. So I could just split it apart and store it as three separate attributes, right? This would be the most common thing to do. I could also do what I call application serialization, where I just store it as either JSON directly inside the database server, and I have to write SQL code and application code to pick that apart. Worst case scenario, I could just use a client-side serialization library, like protocol buffers, thrift, to basically turn this thing into a blob and store the blob inside the database server. That's a terrible idea. Don't do that. But some systems will allow you to support user-defined types. And actually, this is what the big idea of Postgres, one of the big ideas that Postgres created in the 1980s. Postgres, was built to be this extensible database server so that you could add these user-defined types for all these different types that may be out there that the application, that the database server wasn't going to support by default, or the SQL standard didn't specify by default, right? So again, Postgres defined this in the 80s, but then now it's in the SQL standard. And is this idea of these, what we call object relational databases, object relational model. Just think of like the relational model that's extensible. Right? And this was a way to adopt a lot of the ideas that came out of like object-oriented programming in the late 80s, early 90s. There's a whole slew of these database systems called object-oriented databases. They're all dead or almost dead. JSON, XML is basically the same idea. But the idea is that instead of having the strict scalar or atomic types in the relational model, you could extend them and have more complex things. So it sort of looks like this, right? So I can call create type, and I can specify the type to be a composite of the built-in types. This is how you do it in Postgres. Oracle, we define as an object. If you need something even more complex than this, though, you can write UDTs in actually C, or if it's SQL Server in .NET, and then you embed that inside the database server. And then now the data system basically it has a bunch of libraries and routines that deal with integers and strings and so forth. Now has it for your type, which is, again, a really powerful idea. Quick example. Right, so I can create my type, my coordinates. Well, I did it before, assume it's that. And then I have this object tracker table. So I'll define my table to have an integer field and a location. I'll insert some basic data. And then now I can do select star from object tracker, right? And I get back that composite type as a as a tuple, right? Again, think of it like a macro, but the issue is that the database server doesn't know anything about your type. So if I call select sum on that location, what should the result be?
An error.
Yeah, an error. So if you want to support, additional, the additional operators you want to do on these composite types, you'd have to define that again. You would write in C or C++ the sum implementation, or the plus operators, the equals operators for all these things. For composite types, equals pretty easy, but if you want to add two coordinates together, what does that mean? The data system doesn't know what you're trying to do, right? The question is, can you index? Well, let's find out. The answer is, I think, yes. Why wouldn't you? Well, for this type, for a composite type, I'm assuming that it knows how to do equals, right? So create index.
So under the hood it's JSON? Or?
His question is, under the hood, is this JSON? No. I think this would be stored natively. It's like the native primitive type.
So the only reason that sum's not working is because there's a string, like if you had only two.
His question is, we can find that out. Let's see. So you can index it. So can I do this? Select star from object tracker, where location equals, and then I'm going to do something kind of ghetto. Let's see if this works. See what it'll last me. I don't think it's going to let me cast it as a coordinate. It did. Damn. Okay. Postgres.
Maybe it's just storing it as a blob or JSON.
It's quite. I doubt it.
Can you index a nested view location.x?
Can I index? Oh. So over here. So. Nope. Can't do that.
Sorry, could you explain the explain to the previous one to see whether they did an index scan?
With two tuples, I think it's unlikely, but yeah, it's because it sits in a single page. So probably, actually, then the question is, can I do? So I can do this, right? I can just do select, but can I do this? No, because it doesn't, because I didn't define the plus operator for the coordinates type. Okay, good. All right, the last thing I want to show you, before you got in the real world, another thing you actually will see is also views. So view, you think of a view as like a virtual table that is going to be defined based on the output of some select statement. And you can then query them and access them as if they were a real table in a select clause, but underneath the covers, the data type is going to know, oh, you're accessing this view. Let me translate that view into the actual SQL statement that you need, right? And the advantage we're going to get for this is that for really complex queries, we can just define it as a view and then get that reuse where everybody doesn't have to re-implement the same logic on a table. They can just query the view, right? But I will say it's not going to, the data set is not going to run magically faster because you have a view defined, because again, it's literally almost like a macro going to just drop it in and over top of the declaration or the invocation of the view. Another common use for this is that you want to be able to hide a subset of the attributes from certain users. It's another way to think of, like, you can implement security, right? Instead of having column level access, you can do sort of role access based on views or tables. So if you want some group of people to only be able to see some columns, then you define a view on the underlying table and make sure you don't include those, right? The craziest database schema I've ever seen was some SAP, and they had thousands of views because their application is 50, 40 years old, and it's just views on top of views on top of views on top of views, right? They make a lot of money, but the views are very common too. So here we can go back to that student table we had at the very beginning. So I can create a view where I only want to see the CS students. So when I define my view, I define and give it a name, and that's going to be treated as if it's the table name. And then I have my as clause, and the query comes after that. So in this case here, I'm filtering. I want to say only show me the student ID and the name and the login, and I only want to see CS students, right? So if this is my original table, when I define this view, or I run a query on this view, I would only see me and the RZA, right? And this is, and say that again, I want to be able to give this access to this view to like, an administrator, someone who doesn't need to see the grades, right? I can exclude it in the output here. And all this is really happening, it's just a rewrite. It sees CS students, and then it takes that select query up here and plops it in here as a nested query. Then you can run it through the optimizer, and it does the unnesting and turning it into a join as needed. All right, so then I can do, again, more complex things like this. You can put aggregates, you can do whatever you want. So the difference between a view and a select into is that a view is only going to be materialized whenever query accesses the view. And it's always going to get the latest data, right? Ignoring transactions, but it's always, every time you call it from a select statement, it then executes the view query. So you always get the latest information. Yes? Isn't it basically like a macro nested SQL queries? Yes. I'll call these virtual views because, again, it's computed on demand. Select into would essentially do the same thing, but this would be a static snapshot of the table at the time you call select into, right? And if I update the underlying table that the select into reference, it doesn't automatically get propagated to the temp table, right? The SQL standard does allow you to modify a view on some rare cases. I don't think Postgres allows this. And you obviously can only do this if there's no aggregation and it's a single table, because you need to be able to rewire it and go back to what the original tuple was. So this sounds nice, but now what if the view query is super expensive to maintain, right? It's 1 petabyte of data. I don't want to have to call every time I invoke the query on the view. I don't want to call the underlying query on 1 petabyte of data. So there's another category of views called materialized views. And the idea here is that the output of the view is computed and materialized and stored as if it was a temp table. And I can potentially have the data system automatically maintain the view as the underlying base table changes, right? So Postgres doesn't do this. Postgres, you call it a materialized view. It's basically the same thing as select into, except they have a refresh command that calls it to propagate again with the latest results. High-end commercial systems, SQL Server in particular, is very, very good at this, where they can have a materialized view where they can basically track the changes to the underlying table and do incremental updates to the materialized view. So think I want to maintain a tally of like the top scores of an online game. It knows that, okay, here this player got this score. I only update that one portion of the view. This is not easy. You're basically reversing a query back to the change that matters to it. There's some systems like Materialize that are designed entirely for maintaining these materialized views. But again, SQL Server is probably the best one at this. And even they're not perfect. There are some queries where it says I cannot figure out how to do incremental updates, and it has to do a complete refresh. Okay, so I'm rushing through this, but again, you'll see views in the real world. Okay, so I was going to spend time at the end discussing, like, okay, why do you guys think nobody does these things? So I'd probably say the most common thing is going to be views. Then it's going to be probably UDFs, and then implicitly then through triggers. User-defined types are going to be rare. The change notification is rare, and stored procedures are rare. So we already discussed a bunch of these things, and I first said that PLPG SQL, PL SQL is an archaic language. Nobody's here has ever seen it before. Like it's not something that people would like pick up and learn, right? The other challenge is that it's super hard to debug, right? What did I show here in the terminal? I was just like trial and error, just trying to get this thing to compile. The debugging tools are just almost non-existent. SQL Server is better, Oracle's a little better, but like Postgres doesn't have anything. It's trial and error. The other thing is that if you have a database administrator, they're very conservative. They don't like a lot of changes to your database. So if you're trying to do like an agile software development and would have 2-week sprints, and every 2 weeks you have new stored procedures or new UDFs that you want the DBA to install, they're not going to want to do that because they want to vet everything before you make any changes, make sure there's no performance degradations or cause any problems. So if it takes your DBA a month to approve whatever UDF you want to install, you're never going to get anything done. It's better to just do it in the application code. Now you potentially need to also maintain different versions of UDFs because you may be doing rolling updates. And so some database, some servers, some applications are using the new version, some applications are using the old version. But now I need to maintain different versions of the UDFs because maybe calling different things, right? And then also now I would have, in terms of deployment, things have gotten a little bit better with like Terraform and other ways to do like CD and CI. But you would now maybe your application has its its version history over here, and then there's this other UDF version history over there. To make sure things are installed, they're always in sync. It's non-trivial. In many cases for small shops, it's just faster and easier from a development side just to keep everything in the application code. The trend we see oftentimes in the real world is that you start off doing all application logic, and then as things get slow and you need things to run faster, then you start pushing things incrementally into the database server, right? You sort of figure out what's the slowest thing, what could I speed up, and push that in. So I guarantee if everybody's here to start a brand new startup, you're not going to build any of these things, UDFs. Triggers you probably would use. But then if you go to a more, I don't say older, but like a more mature application code, you'll probably see a lot of these things. And if it's Oracle, good luck. So, okay. Any questions? Quick, is it quick? So what is between this and OLAP system?
Yeah.
You can do all this in any OLAP system, OLTP system. They're orthogonal. Okay. All right, hit it.
Strike for the day cold, it's taking its toll. I got a pack of zigzags, but ain't got nothing to roll. Hit the buzz spot, let me cop a dub, show some love. 3 for 50, is you with me? What I'm speaking of? I'm in the studio at 9, so it's on. And I'm not leaving till I'm finished with my next song. Fucking with that dope, you know it make my legs flow. Just grab a double deuce or 2 and then I'm good to go. Yo, I get this shit done and get it over with. Cause the whole world's waiting for another Town street sound. Clown a motherfucker if you label me a fake. I'm like a cobra and I'm down with the super snakes.